In this video, I am going to discuss two-dimensional geometric transformations. Two-dimensional geometric transformations. Um, Here, I'm going to discuss five uh, transformations. First one is translation. Then I will discuss rotation. After that, scaling. General pivot point rotation. Finally, general pivot point scaling. These are the five transformations I'm going to discuss. So now let's look at the first one, translation. Translation. So this is the y-axis and this is the x-axis. Here we have the origin. Now consider a point with coordinates x, y. Then this point moves along the positive direction of x-axis by an amount of tx, and again along the positive direction of y-axis by an amount of dy, and then this point reaches the position with coordinates x1, y1. So we can write down x1 means x plus tx, y1 means y plus dy. So this point now transforms to this one in this way. So this kind of transformation we call it a translation. So now in order to deal with transformations, it's easier if we incorporate the idea of matrices. For the time being, let's say we represent coordinates of this point using this matrix with there are two rows and one column. So the type of the matrix is 2 cross 1. Therefore, we can represent this one like this: x1, y1, 2 cross 1. So now we have this one, the matrix that represents this point its type is 2 cross 1. And now here we have x1, y1. Its type is 2 cross 1. This one we can write by substituting from these two equations. X1 means x plus dx, y1 means y plus dy. Now here we have to find the matrix such that multiplication of these two matrices gives this matrix. So, in order to be able to multiply these two matrices, the type of this matrix must be something cross 2. So, here 2, therefore, here also we should have 2. And the number of rows of this matrix is 2, therefore, here it should be 2. And this one 2 cross 1. Now, this is a 2 cross 2 matrix, therefore, we have to find 4 values. Now, if we try to find the elements in the first row, in order to get this term, here we can put 1. 1 into x, x. Now, there are no y terms here, therefore 0. 0 into y, 0. But we do not have a way to get tx. We cannot get tx. Therefore, now we can understand we cannot find this kind of a matrix. We cannot find. Therefore, what should we do? We cannot find a 2 cross 2 matrix such that if we multiply these two matrices, then we can get this one. Therefore, we have to apply a trick. We represent a point using this kind of a matrix. This is a 3 cross 1 matrix, 3 rows and 1 column. So, the last element is always 1. So, if we represent this point, the corresponding matrix is this one. Therefore, now similarly, this point, how can we represent it? X1, Y1, and then third element is always 1. So now this one is a 3 cross 1 matrix. So here again we can substitute from these two equations. X1 means x plus dx, y1 means y plus dy 1, 3 cross 1. So now here we have to find the matrix. In order to be able to multiply these two matrices, the type of this matrix must be something cross 3. Here 3, therefore here we must have 3. Now the number of rows of this matrix is 3, therefore here we can get 3. Now this is a 3 cross 3 matrix. So in order to get the first term here, now we have to think about the first row. in the first row we have 3 elements. In order to get x, we can put 1 here. 1 into x, x. Now no y terms, therefore 0. Now we have tx. Here we put tx. Now 1 into x, x. 0 into y, 0. Tx into 1, tx. We can get the first term. So, similarly, the second term, no x terms here, therefore 0. Here 1, and here we have dy. So now we can get this. Now finally, in order to get 1, no x terms, no y terms, here we should put 1. Now this is a matrix of type 3 cross 3, and it can transform this matrix to this. Therefore, we call this matrix as the translation matrix, and we represent it using capital T. Here we put Tx, Ty. That means the amount along the positive direction of x-axis and the amount along the positive direction of y-axis. This is translation. Now let's look at rotation. So this is y-axis and this is x-axis. Here we have the origin. Now suppose we have a point with coordinates x, y. So this point rotates around the origin in anti-clockwise order. Anti-clockwise order rotates around the origin in anti-clockwise order by an angle theta. So here we have theta. So now if the length of this dotted line segment is r, then definitely length of this one is also r. So now let's take the coordinates of the new position is x1, y1. Now let's draw a normal to the x-axis here, and from here we draw a normal to the x-axis. Now if we consider this triangle, and then let's take this angle as alpha, this angle alpha. So if we consider this triangle, x means r cos alpha, y means r sin alpha. Now let's consider this triangle. So here x1 means r cos theta plus alpha. Here now we can expand r cos theta cos alpha minus sin theta sin alpha. Then r cos alpha minus r sin alpha sin theta. R cos theta means x minus r sin alpha means y sin theta. So this is x1. Now let's try to find y1. We use the same triangle. Y1 means r sin theta plus alpha. Y1. So here r sin theta cos alpha plus cos theta sin alpha. Now here r cos alpha sin theta plus r sin alpha cos theta. R cos alpha means x sin theta plus r sin alpha means y cos theta. So now using these two, now x1 we can get x1 x cos theta minus y sin theta. Y1 means x sin theta plus y cos theta. X1 and y1. Here actually this point rotates around the origin in anti-clockwise order by an angle of theta, and then it reaches to x1 comma y1 position. This is called a rotation. And now we could get these two equations, x1 from x, y and theta, y1 also from x, y and theta. Now um, if we represent as usual, we represent this point using a 3 cross 1 matrix in order to maintain the consistency, because in our previous situation we had to represent a point using a 3 cross 1 matrix. Therefore here also we use a 3 cross 1 matrix. Now here we have x1, y1, 1, another 3 cross 1 matrix. X1 means x cos theta minus y sin theta, x sin theta plus y cos theta. Here we have 1. Now we have to find the matrix. In order to be able to multiply these two matrices, the type must be something cross 3. Here we have 3 rows, therefore here we should have 3. Now it is a 3 cross 3 matrix. In order to get the first term, x cos theta, therefore here we have cos theta minus y sin theta, therefore here we have to put sin theta and 0. Now we can get this term x cos theta minus y sin theta plus 0. The second term x sin theta, therefore here we have to put sin theta. Y cos theta means here we have to put cos theta 0. X sin theta plus y cos theta. X sin theta plus y cos theta. Here we have 0, 0, 1. 0 plus 0 plus 1. Here 1. This matrix is called the rotation matrix, and we represent it using r theta. Theta is the angle in anticlockwise order. Now let's discuss scaling. So we have y axis and x-axis, then the origin. So we have a point with coordinates x comma y. Now this point moves to another position x1 comma y1 such that x1 means sx into x, y1 means sy into y. These sx and sy, we call them scaling factors. So x coordinate is multiplied by sx scaling factor, then we get x1 coordinate. Y coordinate is multiplied by sy scaling factor, then we get y1 coordinate. This kind of transformation, we call it scaling. Now, as usual, we have to derive scaling matrix. So here we have x, y, 1. In order to maintain the consistency, here also we represent a point using a 3 cross 1 matrix. 1. And now we have to get x1, y1, 1, 3 cross 1. Here x1 means sx into x, y1 means sy into y, here 1, 3 cross 1. So now here we have to find the matrix. In order to be able to multiply these two matrices, the type of this matrix must be something cross 3. Here we have 3, therefore here we must have 3. Now the number of rows in this matrix is 3, therefore here we must have 3. Now in order to get this sxx, in the first row sx 0 0. Now you can get this term. This one 0 sy 0. Finally we have 0 0 1. This is called the scaling matrix, and we represent it as capital S sx comma sy. These are the two scaling factors. Now let's discuss general pivot point rotation. General pivot point rotation. Now we have already discussed rotation. Actually, rotation means around the origin. Here, now let's consider y-axis and x-axis. We have the origin. So, suppose that we have a point with coordinates x0, y0. Earlier, we derived rotation matrix when the point is rotated around the origin. Now, in this situation, our point, this is the point, it rotates around this point. This point is called the pivot point. Okay, so now rotates around this pivot point in anticlockwise order by an angle of theta, and it reaches x1 comma y1. Now we want to derive a matrix for this transformation. Um, so in order to do that, let's use the matrices we have derived so far. Now this one, 3 cross 1. So now the coordinates of this point here we have. This is the matrix that represents this point. So to this one we apply this matrix. Here we are going to put t minus x naught comma minus y naught. So here we should have 1 0 minus x naught 0 1 minus y naught 0 0 1. So with that means so in order to simplify our understanding, suppose that we have x naught y naught here, this point, then multiplication of these two matrices uh, will give us what? 0 0 1 3 cross 1. This matrix uh, represents the origin. That means if we apply to this point, if we apply this transformation, it comes to the origin. That's the idea. So now actually we are going to use x, y, and here what should we get there? If this reaches to here, to this coordinates, these coordinates we apply same amount along the x-axis and same amount along the y-axis. So so it will come to somewhere here. This point will come to somewhere here. Let's say it is our position 1. Its coordinates uh, we, we can compute. No? So this is the matrix that represents this point. So now this point we can rotate around the origin by an angle of theta. So here we put the matrix 3 cross 3. This one r theta. So we have already derived this one, cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. So now if we multiply these two matrices, you get this one. Then to this matrix we apply this one. That means to this point. Then what you get? Another 3 cross 1 matrix you will get, and its position is here, theta. Then its position is here, 2. So this one represents the position 2. So now we want to get the matrix that represents this point. So now what happens if you do something like this? Here we put a translation matrix again with amount x naught comma y naught. So we can expect this point is moved to here. This point is moved to here if we apply this transformation. So we get here 1, 0, x naught, 0, 1, y naught, 0, 0, 1. This is a 3 cross 3 matrix. Now, if we multiply these two, you get another 3 cross 1 matrix. Actually, this matrix represents this point. Let's say this is 3. Position 3 means actually these coordinates are x1 and y1. Therefore, here we have x1, y1, 1, 3 cross 1. we can multiply these three matrices, and then we will get a 3 cross 3 matrix. So uh, you can multiply it by yourself and try to get this matrix. Cos theta minus sin theta minus x naught cos theta plus y naught sin theta plus x naught this is a 3 cross 3 matrix. These are the elements in first row. Cos theta minus sin theta minus x naught cos theta plus y naught sin theta plus x naught. The second one is sin theta cos theta minus x naught sin theta minus y naught cos theta plus y naught. Finally, the last row 0, 0, 1. Now, this matrix is transformed to this matrix by this one. Actually, this matrix, we call this matrix as the composite transformation matrix for general pivot point rotation. So now let's look at the final transformation we discuss here. General pivot point now we have y x-axis, here we have the origin. Now we have a point x naught comma y naught. Another point x comma y. Now we have already discussed scaling matrix. Actually, that scaling matrix xy, this is transformed to Sx x sy y. Here x coordinate, directly we use the x coordinate and y coordinate. So the scaling we have already discussed, that is relative to the origin. Here what we are going to do is we are going to scale with respect to a pivot point. This is our pivot point. So now we have to think as in general pivot point rotation. So here we have 1 3 cross 1 matrix, and so first what should we do? Here we write down the translation matrix with minus x naught minus y naught, 1 0 minus x naught, 0 1 minus y naught, 0 0 1. Now what should we do? After that, so you have to compare with general pivot point rotation. Here what should we do? Now once we have translated this, then we can scale with respect to the origin. So here we put s simple sx comma simple sy. Now sx 0 0 0 sy 0 0 0 1. So now this is a 3 cross 3 matrix. This is also a 3 cross 3 matrix. After that, again we have to translate reverse process of this one. We have to perform x naught comma y naught. Now here 1 0 x naught, 0 1 y naught, 0 0 1. So finally we can get the position x1 comma y1. That means if we scale this point with respect to this point with scaling factors along the x-axis sx, scaling factor along the y-axis is sy. So then we will get this one, this coordinate. So here now we have 1 by 3 cross 1 matrix. So here we have x1 y1 1 3 cross 1. So here we multiply these three matrices, and you can do it by yourself and then try to get this one, sx 0 1 minus sx into x naught. These are the elements in the first row. Then the second row, 0 sy 1 minus sy into y naught, 0 0 1. This is a 3 cross 3 matrix, and here we have x, y, 1, 3 cross 1. Now this matrix is transformed to this matrix using this one. Therefore, this matrix, we call this matrix as the composite transformation matrix for general pivot point scaling. Okay, this is the last one, and I hope you could understand very well, and thank you for watching.